Bismillahirrahmanirrahim. Assalamu alaikum and good morning to my students. So, we have already completed 7 chapters in mathematics, and the book was, uh, I have already shown you book many times. But parallel to that, I am going to start from today and onwards uh, the lectures on physics on the alternate days. One lecture will be from physics and one lecture will be from mathematics. And the book, you know that you are doing this book. Yeah, this is the book. And Physics for Cambridge IGCSE, and it is written by David Sang, Mike Follows, and Sheila Tarpe. So we are going to start this book from today on. In fact, uh, some requests were made to me that I should also teach physics along with the mathematics. So I am here because your request is my respect. Okay. Now, in physics, the first chapter is about measurements, and we are going to start right from measurements and or making measurements. The uh, topic of this chapter is making measurement, and the first is measuring length and volume. So measuring length and volume, we are going to study now. This is measurements, okay, and making measurements. The chapter name is making measurement 1.1. So we are going to measure the length and the volumes. And about length, God has given us many tools on our body to make the measurement. For example, this. You see this? So this is a very important tool to measurement, like this. In on ancient days, people used to measure it like this: one, two, three, and four. Okay. Though the measurement was not so hard and fast, and even that this length varies from human to human hand. So this is not so authentic. And then this from here to here up to the forearm, this elbow is which was considered as one lead. This was considered as one lead. It was also used like this, and again the problem varies that the lead varies from human to human, but the average was taken at that time. The average was taken at that time. So it was all approximations, and even thread was used to measure this, and then the thread was he the measure thread was not known that how many feet it was, how many inches it is, how many meter it is, but it was just to compare that if this is the thread from here to here, then I can compare this thread from here to here. Okay, so 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 you can compare this thread from here to here. So this was the compare, and then what came? Then came the measuring tools. What were the measuring tools? The measuring tools were yards, fits, foot, ruler, or you can say it ruler, scale, whatsoever you can say it, scale, yards, foots, and if we come to the metric system, then the meter came into being, and the in meters, centimeters, and millimeters. So we'll be discussing a very short thing about these. Now there are some four systems of measuring, which is FPS, MKS, CGS, and international measuring system. International measuring system, all which is all in this MKS system. But a very refined MKS system is the international measuring system. So, my dear students, it is very easy now for you because we are in this age. We are not in the ancient age. Now we can measure with the tape, with the scale, what we do have in our homes and in our geometry books. Now you see that this is a scale of inches, this is a scale of uh, centimeters, and similarly I have. So my dear students, we do have some foots. This is ruler, you see, this is my teacher's ruler, okay, because it has handle. So we have a ruler or scale, whatsoever you can call it. So above it is inches, and here we have centimeters on it. Similarly, there are these scales as well. And to measure the angle, we do have a protractor. Okay. Now these were the different tools we can use. But let me introduce you to the systems first. Okay. Then I'll be going to the uh, detail of what we are going to measure. Okay. Now yards. First of all, I have written yards. Now yard was the unit of measurement of length in FPS system, foot pound system. Foot pound system. It is called foot pound system. So foot pound system for measurement uses foot. Okay. And for weight, pound was used, and for time, seconds was used. Now time remains same for every system, seconds. Okay. And in MKS system, what we have here is meter, kilograms, and again seconds. As I told you, in every system, the unit of time remains same. Now this is time, this is weight, and this is length. Okay. CGS system, centimeter, grams, and again second. In international system, there are millimeters, okay, and milligrams, and seconds again, or microseconds, you can also say it. Microseconds, it is also written, it's like this, microseconds. Now you see, my dear students, for 3 feet we use yard, a combination of 3 feet. Now there is 1, 2, 3 feet. If this is 3 feet, it was called 1 yard. It was called 1 yard. Okay. So this was the brief discussion about the units of the systems. FPS, MKS, CGS, international systems. Okay. Now, how can we measure it? Now, suppose we have a scale. Now, nowadays, and in Pakistan and in many countries, now this system is used, MKS, metric system, okay, or this international system. Now, if I have a scale, and it measures 30 centimeters. Say it measures 30 centimeters, because a small scale is about 30 centimeters. You see, it is about 30 centimeters, 30, 35 centimeters or 30 centimeters. So it is 30 centimeters. Okay. Now, if I am going to measure a wire, so I have to put one point over here, the starting point of the wire, and the end point up till here. So it will measure me, it will give me 30 centimeters of wire. Okay, it will give me 30 centimeter of wire provided. Now, just there is some weight in provided. Okay, because what I am going to tell you is very important now. Suppose you have placed a wire straight, dead straight, dead straight. It is 30 centimeters. Okay, but if you have placed the wire like this, it will not be 30 centimeters anymore. It will not be 30 centimeters. Maybe it will be 30.5 centimeters, 31 centimeters, or whatsoever. Because curved path is always bigger than the straight path if made on the same points. Understood my point? Now you see that error has begun to come. The error has begun to come. The 13 centimeter is giving us 30.5 centimeter or 31 centimeter or maybe 29.5 centimeters. Maybe sometimes. If I stretch the wire very hard, then maybe I am able to measure it 29.5 centimeters. In the end, which should have been 30 centimeters. Now, my dear students, now you see the error has begun to come. Error has begun to occur now. Now, if I keep on measuring like this in the curved path, now the error is recurring now. It is passing to the next measurement, next measurement. And in the end, maybe if I have measured it like this, in the end, if suppose I had to measure it 10 meters with this ruler, so and I have measured it like this, in the end, I may have this wire as 11 meters. Or if I have stretched this wire very hard, wire very hard, and in that maybe I have 9.5 meters. So you see that the error has occurred. The error has occurred in the measurement. So the tools vary from tools to tool. For example, you have only this ruler, only this scale to measure, then there is no harm of wire being 10 meters or 11 meters. Maybe there is no harm in 1 meter, or there is you see that there is an error of 1 meter from here to here. But when we go to the precision, now this harm which we made of 1 meter is very much greater. This is very much greater. Now, what we used to minimize this error, we use a larger scale, a inch tape or measuring tape to overcome this error. to overcome this error. For example, I have an inch tape. I may tell you this. Now, my dear students, if you want to measure it, the 10 meters out of it, you can do it with much more comfort and on easy and less tolerance. If you want to measure 10 meters with this tape, now there, now it is visible to you. Okay, if this tape, now the percentage of error will be minimized because you are going to measure it in one go. You are going to measure it in one go. So maybe, for example, say this is 10 meters. This is not 10 meters. But anyway, just suppose it that this is 10 meters. So from here to there. Okay, then your error will be minimized. Your error will be minimized. Though this was the case with the length. And if you want to measure the thickness. Now, thickness may vary. You see that this is also thickness. This is also thickness. The thickness of book. The thickness of book. The thickness of book. Maybe now you can also measure it with this ruler, simply with this ruler. So suppose this is 2.5 or just say it 25 mm. So this book is 25 mm thick. But if you want to measure one page out of it, the thickness of one page, what will you do? You cannot measure it with this. You cannot measure it with this. You cannot measure it with this. So you are stuck here. You are helpless. But there is a technique now. There is a rough technique or thumb rule here that when this stack of paper, you know that there are how many pages in this book? There are some 510 pages in this book. There are 510 pages excluding the cover pages, because the thickness of the cover page is different from the thickness of the page. So there are 510 pages plus some pages which are not numbered. So we can also add them with the maybe there are 20 pages. So there are 530 pages in this book. 530 pages, for example. Now you can measure it with now 530 and you can measure it with this the whole stack. You will measure the whole stack with this tape. Whole stack with this tape. Like this. Okay, now I am going to measure the whole stack of the pages with this paper. Now this is 23 mm. I told you that the measurement of my dear students. Now the thickness. We have already discussed about the length and now about the thickness. Now this is the thickness from here to here. T thickness. Now this thickness is very less when we measure a page. Maybe this line represent the page. Okay. Now I don't have any tool right now to measure this page, the thickness of this page. I don't have any tool to measure the thickness of this page because it is very thin. It is very thin. I cannot measure it with scale. I cannot measure it with the measuring tape. This is called measuring tape. I cannot measure. But there are certain tools like vernier caliper. We'll be studying that in due course of time. Vernier caliper, calipers, micrometers. I do have a vernier caliper with me. I'll show you. Okay. Now, what technique I had to use? I put a stack of papers. Now, I put how many stack of papers? There were 530 papers. I told you. There were how many papers? There were 530 papers. So there were 530 papers, and the measure was 253 millimeter. So I can calculate the thickness of one. I can calculate the thickness of one. So how? Just divide. Just divide the thickness of whole stack with the number of pages. Now, my dear students, now this is the vernier caliper. Okay, this is the vernier caliper. We can measure it thickness from here, hole from here, and depth from here. Okay, there are three facilities in this. Okay, I'll teach you when the time comes. Okay, now how many it measures 253 millimeter, and the number of pages were 530. So it means that about 0.47 millimeter is the thickness of one page. Is the thickness of one page. Now this is 0.47. 0.47 is approximate, because when I measured the whole stack, maybe there was air in the between the papers. There were air in the between the papers. So it is again a count of error. We have made an error. Now if I measure this page with this vernier caliper, so my dear students, I can measure this with this help of this vernier caliper. So take one page from here and just measure it. Oh my god. Oh my god. Oh my god. There's a great difference. There is a great difference. It is only 0.25 millimeter. It is only 0.25 millimeter in actual. So you see that how we made the error. And when we go to the precision, we have to take the special tools for that. And if I go to costing, then more precise you are, the more precise you are, the most costly you are going to incur on that product. The more precise are you going, the more cost is you are going to incur on that product. And as much rough are you going to do, that means you are going to manufacture a cheaper product. Okay, is it clear to you now? Now, my dear students, let me go to the next point on this book, which is measuring the volume. Now, measuring the volume is very easy when we have a regular figure. Now, I've already told you about the measuring straight lengths. Okay, this is straight length, but I have also told you about the error we can commit, and about the thickness. Okay, and also about the precision and non-precision or rough. Okay, if you want to make precision things, then you have to apply special techniques. You have to apply special tools for that. And even I do have only vernier caliper with me, but if I would have taken micrometers with me, then this measurement would have gone like this. See, 0.254, maybe 0.254 up to thousandth of the millimeter. Okay, now you have already known about the length, about the uh, thickness of even the page of hair which I don't have on my head. So now about volume. Now, my dear students, volume. When we say volume, I have already told you volume. I have just finished perimeter area and volume. Perimeter area and volume in my maths lecture. I've just finished it. So volume, if you have a regular figure like this, if this is, you see that this is a regular figure. It has length. It has length. It has breadth over here, or width. You can say it. The width. This is the length. This is the width, and this is the thickness. Exclude the rubbing surface. This far. Exclude this far over here. Okay. We are going to take the volume. This block only. This block only. So you see that this is. Let me measure it. Why don't I measure it straight away? Suppose that this is 10, length is 10, 10 cm, breadth is how much? 5 cm, and the thickness T or height. You can say it height or thickness. It is 12 cm, 1.2 cm. Okay. Now it is very easy, as I told you in mathematics, that volume of a regular figure is area multiplied by its height. Now what is the area? This is the area. Length into breadth is the area. Length into breadth is the area, and again multiplied by its height. For my ease of calculation, I am going to take it 1 centimeter. Okay, for my ease. Okay, this is for my ease. Okay, now this is 10, this is 5, and this is 1. So it becomes the volume. Now this is the volume is 50 what? Centimeter cube, or you can say it's cc, centimeter cube. You might have heard cc when you are going to have an injection over here, that you have a 5 cc injection or whatsoever it was. So cc means cubic. This is cubic centimeter. This is cubic centimeter. Now it is very easy. Now you can take the volume of this cylinder as well, because this is a regular cylinder. Pi r square area. Yes, the area multiplied by its length. Now it is length. It is the volume. And I've already told you in my math lecture about the area of prisms, pyramids, spheres, and for example, the volume of sphere is 4 by 3 pi r cube. Okay, so there are many formula for the regular figures. For the regular figure, but what if you want to find the area of a stone? Now this is a stone, irregular stone, and it has some mass. Okay, this is a stone, Okay, you want to find the area of this. We have measured the volume with this with the, of the sphere with the help of this formula. But if we have a irregular shape of stone, what we will do then? What will we do then? Let me touch Archimedes principle. Archimedes principle. Archimedes principle. You might have heard the story of Archimedes. Might have heard the story of Archimedes, a king of that time, given him a crown, and he said, just find the volume of this crown, and if you are unable to find, you will be beheaded. You will be beheaded. So he was a scientist, and a scholar. He thought and thought and thought and thought and couldn't get to any result. And by the time he went to get fresh in his bathroom, when he just went into the bathroom in his bathing tub, this was his tub. Maybe there were some taps over here. It was filled with water. Bathing tub is always filled with water. So when he jumped in this tub, the water just flew outside. The water flew outside of the tub. And I don't know it is a story or whatsoever it is, how many truths is in this. He went all naked. And what he told, Eureka, 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 Eureka. Eureka means I found it. I found it. I found it. He ran in the streets all naked and he was shouting Eureka, Eureka. Okay. What he found, that when he went in the bathtub, the volume of his body just displaced the water of an equal amount of his volume. So this is the Archimedes principle. Then later it was called the Archimedes principle. Now we can measure the volume of the stone by the help of Archimedes principle, but we are not touching this Archimedes principle now. We'll just be going through with the same experiment what he did. Okay. Well, my dear students, I was discussing about the Archimedes principle, but I told you that I am not going to discuss more in detail about the Archimedes principle because so I am only touching the volume. So let me tell you one thing, that how we did the volume of a irregular stone or irregular body. You can say irregular body. Now, for example, this is a cylinder. This is a graduated cylinder. This is a graduated cylinder. A graduated cylinder have graduations on it already marked on the cylinder. You might have seen this cylinder in your labs. Okay, now there is one point. What is a parallax error? I am always speaking right from the beginning about the errors in the measurement. So there is also a parallax error which occurs when you read the liquid in the cylinder. When you read the height of the liquid in the cylinder. Now what is the height? In fact, it is called column. Now, for example, Now, my dear students, there is a liquid in the cylinder. Now, there may be two types of liquid in the cylinders which we can measure, or which we can read through the graduations. Okay. Number one is the clear. Number one is the clear liquid, just like water, transparent, or you can say it a transparent. Now, I always use X for trans. Remember this. I will always use X for trans when I say transistor, when I say transformer, when I say transmitter. So I only write X for trans. So transparent. So transparent liquid which is clear, for example water. Now, how to read water in the cylinder? How to read water in the cylinder? Now, I was telling you about the parallax error. Now, your eye should be over here. Your eye should be over here, right in the side of this level. I'll tell you what is the name of this level. I'm going to tell you. Just watch it carefully. That it should not be like this. Your eye should not be like this, and your eye should not be like this. These are three possible. These are three possible ways how I can read this cylinder. Now, for example, this is a cylinder. Now, I should be reading it like this, right in front of me, right in horizontal to me, my eye. Okay, I should not read it like this. I should not read it like this, because every liquid, every liquid, when it is poured in into the cylinder, it a meniscus is appeared, which I was telling you about the level. Now, the upper level is like this in the cylinder. This is liquid. This is liquid. Maybe water, or maybe alcohol, which is colorful, or any other liquid which is colored or clear. I'll be discussing two. Number one is clear, and number two is colored. Yes, this U is used in British English, so you can use it like this as a colored. Now, this liquid, when it is put in this cylinder, it will appear like this. Why this happens? There is a force of attraction of the glass. Now, maybe the cylinder is of the glass. Maybe it is glass because it is transmitted. You can see in the transparent. You cannot see if I put this liquid in the stainless steel, or I put in some metallic cylinder. So consider this is a glass cylinder, and the force of attraction on the corners, of the, because it is like this, it is round. So a force of attraction pulls the end of the liquid to upward. Now, this force has also a name. Force has also a name. Okay. There, now let me tell you a little thing. I just touch the little thing. Now, suppose these are the molecules of water. These are the molecules of water. Now, there is a force between the molecules of water. Okay, there is a force between the molecules of water. They are just pulling each other. They are pulling just each other. There is a force between the two molecules of water. And when this water is poured into another thing, which is glass, now the molecules of glass are also there. The molecules of glass are also there, and there is a force which is pulling this water molecule towards itself. So there are two kinds of force: a force between its own molecules, a force which is between its own molecules, and force which is outside outside the molecule. That means the container in which it is kept. The container in which it is kept, one is called cohesion force and other is called adhesion force. Okay. Now this is not discussed in your book. I've just seen it. But the only thing which I'm going to tell you that this curved surface will appear. This curved surface will appear here, right here. Okay. Now this curved surface will appear right here. Now parallax error. Parallax error. Now let me set aside the parallax error and let me tell you what is this surface called. This is called meniscus. Now this surface is called meniscus, which is curved like this. Like this. Okay, it is curved like this. For the clear liquid or water or transparent, you will read the lower meniscus. This is called the lower meniscus. This is called the lower meniscus. Now if this is, yes, this is, now you will read the lower meniscus. This is called the lower meniscus. And for colored, you will read, because you will not see this in the colored liquid. You will not be able to see the lower side of the meniscus. Then you will read the upper meniscus. Okay. Now I think I made my point very clear that there are two meniscus in every liquid when put into a cylinder or anything else. Now I am talking about the cylinder because it is easy to be read, or it is easy to see through the meniscuses in the cylinder. Okay. Now the parallax error. Now if you see here, for example, it is 87 millimeter. 87 milliliter. But if you see it from here, you might see it 89 milliliter. If you see it like this, if your angle of sight is like this, you may read it a point or two above, which is actual level of this liquid. And if you see the angle of sight is above your meniscus, then you will see it like this, and you see that it is already crossing 89 and 80, maybe it is 85 milliliter. So you see how this is example, just the example is given to you that how the parallax error is occurred. How the parallax error is occurred. And do tell it once again, I may tell you that for the clear liquid you will read the lower meniscus. For the colorless liquid, clear liquid, transparent liquid, you will read the lower level of the meniscus. This is for the colorless liquid. Colorless liquid, just like water. My dear students, मेरे अच्छे बच्चों, and what will we read for the colored liquid? It is colored liquid. It is the upper side, which is called the upper meniscus of the liquid. So you must avoid the parallax error when you are going to read such things. Now let me tell you about the quantities and the units. Let me tell you about the quantities and the units what I have read so far. And with this we'll be finishing our lecture today and be doing it on the alternate day because I have to deliver a lecture on mathematics probability. Now for the length, as I told you, in my lecture in earlier in the lecture that there are how many systems? There are in fact four systems. How many systems? There are four systems of measurement. Four systems. What are they for? But we always be doing only one system or two. Four systems. What are the four systems? Because FPS system, let me tell this FPS system, it is very complex system. Very much complex system. You see, the smallest unit of the is inch. It is not the smallest unit, inch. And the inch is subdivided into 8 subdivisions. 8 divisions. And then 8 divisions are also divided into 8 more divisions. Now this complexity arises here when you are dividing this part in 8 divisions, and for further 8 divisions you are going more 8 divisions. That means the smallest so far smaller is 16th division of the inches. That means 1 by 16th of the inch. No, I am not going to discuss it in detail because there are very much complexities. 760 feet is equal to 1 mile, and there are 8 furlongs in 1 mile. There are 220 yards in 1 furlong. Now this is very complex and it is very much difficult to remember or memorize it. You see that each figure is very much more complex, but it has some relation to each other. If the time allows me, I'll tell you what is the relation in between them. But the simplest of the systems is MKS system, CGS system, or International System of Measurement. That is MKS system. Now, the biggest advantage of MKS system is you just shift the point from one side to another, you will get the another unit. You don't have to divide it with 8 or 116 or 220 or 760. You will not remember ever in FPS system. So you have to just shift the position of point from one place to another, and you will get the lower category. That means if you are measuring meter has 100 centimeters, 100 centimeters, and in 100 centimeters, and in each centimeter there are 10 millimeter. How many? There are 10 millimeter. Just shift of point or just shift of zero from just erasing 1 0 from the, you will get the. Now what are the units of length in meter? Now in this system, units of length, let me discuss about the unit of length. Unit of length, meter. Yes, meter. From this we can write meter. The first unit comes is decimeter, dm. It is dm, decimeter. As you know that deci means 10. Okay, so it is equal to 0.1 meter. 0.1 meter. Just follow my point. Sometimes it is very small point. You may not be able to watch it on a small screen of video of mobile. But when I write 0, it is understood that I have put a point in between the figure and the 0. Okay. Now 0.1 meter is decimeter and centimeter. Centimeter is, as just I told you, that centimeter is 0. This was point 1. The centimeter is 0.1 meter. 0.1 meter. Now you see that how the point is shifting itself to get the other unit. Now you see that point is shifting itself to the other unit. Now what about the millimeter? As the name implies, the millimeter. Okay, so millimeter is equal to 0.001 meter. Okay, 0.001 meter. And when the micrometers came, and then the micrometer, or you can also call it micro. This is the Roman sign for micro. Okay, micro, it is equal to 0.00001 meter. 5 zeros in a row. 5 zeros in a row. And if I go upwards, then 1 kilometer will come. If I go upwards, then 1 kilometer will come, and 1 kilometer is equal to 1000 meters. 1 kilometer is equal to 1000 meters. So these are some units which are in your course, and rest are beyond your course. Okay. Now what about the volume? Because so far we have studied the length and the volume. It is going to be very interesting now. I may tell you that. It is going to be very interesting, and we just have to concentrate upon the board and my words. Okay. So you be feeling very much pleasure in you will be feeling very much pleasure in watching my videos, and uh, about what I tell you now about the volume. What I tell you on the board, or what I tell you against the camera. Okay, now the unit which I just erased was about the length, and now about the volume. Now I have already told you about cc. Cc means cubic centimeter. Now let me do. There are only two. 1 cc, 1 cubic centimeter. 1 cubic centimeter is equal to how much? 1 cubic centimeter. It is very easy. If I write here the centimeter, what was the centimeter? What was the centimeter which I just erased? Was the centimeter was 0.01. It is 0.01 meter. It was 0.01. Centi means 100. So it is at the 100 place. 1 is at the 100 place. So it is centimeter. 0.01. Now there are 3 dimensions, because we are studying now 3-dimensional figures. 3-dimensional figures. What is it? Length, breadth and height. Length, breadth and height. So it was only 1 dimension. If I multiply it for 3 times. Okay, now this is for the first time. It will become, if you just multiply it, you see that there are, let me do the multiplication, the simple multiplication of grade 2 or 3. It is multiplied. So it is 1, 0, 0. Grade 1, okay? And then about the 0. So 0 multiplied by 1 is 0, 0 multiplied by 0 is 0, 0 multiplied by 0 is 0. So it came 2 crosses over here. And then this 0 will come, it will become 0, 0 and 0. So your answer be 0, 0, 0, 0, 0. And how many places at the point is 1, 2, 3, 4. 1, 2, 3, 4. So this is the centimeter square so far. This is the centimeter square so far. You have to make it centimeter cube. So again multiply the whole thing with 0.01. The result what will you get is, the result you will get is 1 cubic centimeter is equal to 0.000001. 1, 2, 3, 4, 5. Yes. And if you do it like this, you will get this. It is meter cube. Okay. It is meter cube is equal to meter cube, because we have changed this centimeter which was linear, now it is cube into cubic. We are converting from centimeter to meter cube. So it will become, now there are 3 dimensions, 1, 2, 3. So in meter there should also be 3 dimensions. So if you do it like this, now the first part of it will be same, but the second part, you see that it will become 0 all over. 1, 2, 3, 4, 5. 1, 2, 3, 4 and 1. So 1, 0, 0, 0, 0, 0. So how many places decimal? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it will become 1, 2, 3, 4, 5 zeros in a row and then 1. 5 zeros in a row and then 1. So this is called cubic centimeter. 1 cubic centimeter is equal to 0.000001 meter cube. So this is also converging table. This is also converging table. And 1 cubic decimeter. Similarly, 1 cubic decimeter. 1 cubic decimeter. 1 dm cube. 1 dm cube. 1 dm cube is equal to 0.001 meter cube. So 1 decimeter cube is equal to 0.001 decimeter cube. Now there are questions ahead of us. So should we proceed with the questions or we just finish it, the exercise now, the lecture? Let me proceed with the question. There are 2 questions. So let me finish this topic very quickly now. Now, my dear students, the first question is, the volume of a piece of wood which floats in water can be made in shown in figure 1.8. Write the paragraph to describe the procedure. Now, there is a question, and this question needs some written work. That is, the volume of a piece of wood which floats in water can be measured. Now, I told you about the irregular figure which can be measured by virtue of this cylinder, which is graduated as well. This is graduated as well. Yes, this is a graduated cylinder. Okay, this is a graduated cylinder. Now you see the heavy thing. It is filled with water. Okay, it is about 3/4 filled with water. If I dip a heavy stone, marble, or whatsoever, a piece of iron in this, it will sink and stays here. It will sink and stays here. But if I, if I put a piece of wood, if I put a piece of wood in this cylinder, it will float upward. It will float to its here, or it can flow over the surface. Okay, can float. Something will float under the meniscus, and some things will be floating over the meniscus. Okay, so for the wood, it is known that it will float over the meniscus. Okay, now if I want to find the volume of this, what will I do? You will have to write the paragraph upon it. So what I do now, this piece of wood is irregular. This is an irregular. This is an irregular piece of wood. So what we do, first of all, the first step is we will note the initial meniscus level column of the cylinder. For example, it is 65 ml. The initial, without putting anything in it. For example, it is 65 ml. Now what will we do? This is the initial level. You will write it in the paragraph form. Now the initial level is 65 ml, and what will we do? We'll, in the second step, we'll take a stone. And what will we do? We'll submerge that stone. Okay, maybe regular or irregular, it doesn't make any difference to this experiment. Which we are going to do with the wood now, or the lesser dense material. Okay, now we'll take a stone, heavy thing, a stone, a piece of iron, and then we'll note the level again. Of course, the level will rise. And you will have to note that rise. For example, from 65, it will rise to 68 milliliter. That means there is a rise of 3 ml. In the level. That means the volume of this stone, piece of marble or piece of iron, has a volume of 3 cc. Okay, now third will be, we will tie this. We will tie up our piece in question, which was wooden. Now we will tie the wooden piece in question. It is the wooden piece in question with this stone. We'll bring back the stone and we'll tie this wooden piece with this stone, and then again we'll submerge it. And again we'll submerge this. So we'll again take the second level. There will be rise, which was 68 millimeter with the stone, and now with the wood it should rise more. Maybe it will become 70 millimeter. So what is the volume of the wooden piece? That was 2 ml or 2 cc. Okay, this you can write in what I have stated. State the volume of wood. So it is finished. A stack of paper containing 500 sheets of paper. The stack dimension, what is the signal? Second question I have already done in my lecture, but for your sake I'll tell you again that there is a stack of paper. Now this is the stack of paper. It is very new book, so it is a stack of paper. So it will measure something which is written in your book. So I will try. I'll quote the same figure. The stack of paper containing 500 sheets. Now there are 500 papers, 500 paper sheets. In your book there are 530, I think. 500 sheets, and the stack of the had the dimensions of this and this. Now one page has the dimension of, what was it? Let me bring it closer to me. That is 0.297 into 221. Now it is meter, in meter, it is in centimeter, and it is in millimeter. Now all the three units are given to you. This is this is meter, this is centimeter, this is millimeter. What is the thickness of one sheet of the paper, and what is the volume of the stack of in? Now we have to find the thickness. A, thickness of the paper, and B, the volume of the stack of paper in, and also the volume of one paper, not the whole book, because it is very easy that you will measure here and there, then here. It is very easy, but when it is given you in meter, centimeter, and millimeter, and volume is required in centimeter cube, you will have to change this into centimeter and this into centimeter. You will have to rise to it to centimeter, and you have to lower this meter into centimeter. Then you will be able to find the volume in centimeter cube. So let's have a break, and then I'll welcome back after the break. Now, in question number 2, what data is given to us is there are 500 paper sheets. There's a stack of 500, like this book of yours. Okay. Now, there's a dimension given. There are the dimension given: 0.297 meters, 21 centimeter, and 50 millimeter. Now, all the three are different units. Though they are in one system, but this is in millimeter, this is in centimeter, and this is in meters. And what we are asked about is the volume in centimeter of one page of the stack of the paper. No, the stack of the paper. We are stack of the paper, not one page. Okay, volume of stack. Now we have to find the volume of stack of the papers. Now this is the total dimension. Now what is the rule? This is the rule that this is the length, this is the breadth, and this is the thickness. Okay, T, and sometimes it is height. Okay, and this is sometimes it is height. So it means that this is the length, this is the breadth, so this is the thickness. When this is the thickness, we want to find the thickness of one page. There are 500 pages, so it will be equal to 50 divided by 500. Just I did it in my lectures somewhere in the beginning. So it crosses this, it is equal to 0.1 mm is the thickness of one sheet of paper. Okay, my dear students. Now what about the volume? Now we have to find the volume in centimeter cube. Okay. Let me do it somewhere here. Okay. Now we have to change this meter into centimeter, this millimeter into centimeter, because the final result should be in centimeter cube. So all the units should be same. So this 2200 meter is equal to 29.7 centimeter. I told you about the conversion table, so you can match it from there. 21 is okay. 21 centimeter is equal to 21 centimeter. 50 millimeters. 50 millimeter is equal to 5 centimeters. Okay. And if you don't know, if you don't understand it, it is very easy to find that in 1 meter. In 1 meter, there are how many centimeters? There are 100 centimeters. 1 meter is equal to 100 centimeter, and 0.297 meter is equal to 29 centimeter. Similarly, this is the same, and in uh, 10 millimeter is equal to 10 millimeter is equal to 1 centimeter. 10 millimeter is equal to 1 centimeter, 550, so it is equal to 5 centimeter. Now we want to find the volume. So all the units are in centimeters now. Now you can easily multiply each, and now you can multiply this with this with this, and the final result will come. So let me multiply it on the calculator. 29.7 so it is equal to 3118.5 centimeter cube. The volume of the book, the volume of the stacks of the paper is this. So my dear students, this ends our lecture for today, and hope you had find it very interesting, and will be more interesting when we step forward. It's time to see you goodbye. Say you goodbye. Allah Hafiz, and don't miss my next lecture.